In the third prompt, they tell us we have this beautiful function right here that is all linear, piecewise function, and they give us this function definition for g, and they ask us, first two questions are really all that stuff from first semester. They ask us about a relative max and a relative min, and they ask us about points of inflection. So here's where we have to recognize that because g of x is defined by the integral of f, and they give us a graph of f, that this graph of f is also a graph of what g prime would look like. And we're going to use those same skills from last semester. So if it has a relative max or min at 10, would mean the derivative of g would be changing from positive to negative when x equals 10. Looking at the graph near 10, I can see that this function is not changing from positive to negative. It goes negative at 0 at 10, and then it stays negative. So the answer to part A is neither. And the reason would be because, well, there's a lot of ways to say this, but anything that says something to the effect of that, it does, the graph, you can say something like f of x, which is equal to g prime of x, does not change from positive to negative at 10. It would be like one way to say it. Another thing you could say is it stays negative on this entire interval. But anything to indicate that you recognize that this graph of f is really a graph of g prime, and to find the local maximum, g prime would change from positive to negative, would get you both the points. Oh, that was just worth 1 point for saying that. Well, 1 point for recognizing that g prime equals f, and 1 point for knowing how to find the local maximum. For part B, also worth just a single point, does the graph have a point? Does the graph of g have a point of inflection at x equals 4? So we would again have to recognize that this graph f is also a graph of g prime, and we have to know from first semester that g is going to have an inflection point if its derivative, g prime, changes directions. Since at x equals 4, f goes from up to down, that means g prime would go from up to down. That also implies that g double prime would go from positive to negative. But we don't need to say all that. We could just say yes, because f, which is equal to g prime, changes directions when x equals 4. And that'd be it. So it's really just about seeing this and recognizing that if you have the graph of f and g is defined as the integral of f, that what you also have here is a graph of g prime, and then using all those fun things from first semester that we're still working through.